Hello everyone. This is the block diagram for IoT protocols. Basically, block diagram is showing the different protocols used at the different layers of IoT architecture. So basically, there are four layers in IoT architecture. First one is link layer, and it consists of different protocols: 802.3, 802.11, Wi-Fi, Ethernet. This is IPv4, TCP, HTTP, MQTT. These are the different kinds of protocols used in the IoT. So what next? Next, we will discuss one by one all the layers, protocols of all the layers. Link layer. Basically, link layer protocols determine how the data is physically sent over the network physical layer. So basically, link layer means it represents the physical layer or physical entities. So how the data is transmitted in between the devices devices. So it may be coaxial cable or any other radio waves, and this layer determines how the packets are coded and signaled by the hardware device over the medium to which the host is attached. So this is the link layer. There are different link layer protocols like Ethernet, and Ethernet is a set of technology and protocols that is used in the LAN, local area networks. Basically, for area networks, we are using Ethernet. It is very common, and it was standardized in 1980s by IEEE 802.3 standard, and it defines the physical layer and medium access layer, MAC sublayer of the data link layer for the wired Ethernet network. And now again, Ethernet is classified in two categories: classic Ethernet and the switched in Ethernet. Next protocol is 802.11. This is Wi-Fi. You already familiar with this word, Wi-Fi, and you have studied this in data communication also. IEEE 802.11 is a part of IEEE 802 set of LAN protocols, and it specifies the set of media access control, MAC layer, and physical layer protocol for implementing wireless local area network Wi-Fi computer. So for the establishing Wi-Fi network, this protocol will be used, and communication between it provide communication in various frequencies, including 2.4 gigahertz, 5 gigahertz, 60 gigahertz frequency band. But this can be expanded also. Next is WiMAX, and this is technology for wireless metropolitan area network and developed by number 16, and this is specialized for point to multi-point broadband wireless access. Basically, this is specialized for point to multi-point broadband wireless access, WiMAX. Then next is 802.15.4. This is collection of standards for low rate wireless personal area network. This is basically personal, PAN is personal area network. So this define the MAC and physical layer used by Zigbee, low power, personal area network, thread for all these. And this standard provide low cost and low speed communication for power constrained devices. So this is also link layer protocol. And next is 2G, 3G, 4G mobile communication. These are the different type of telecommunication generations, and IoT devices are based on these standard can communicate over the cellular network. If you are building any devices based on this standard, then that device will communicate over the cellular network. And next layer is a network layer. This layer is responsible for the sending IP datagram from source network to the destination network. Basically, this is the interface between upper layer and the physical layer. That is transport layer and the link layer. It routes the data, it receives the data from link layer and routes that data to the higher layer. Network layer perform the host addressing and packet routing, and generally we are using IPv4 and IPv6 for the host identification, and these two IPv4 and IPv6 are the hierarchical IP addressing schemes. IPv4, this is an internet protocol address, is a numerical label assigned to each device connected to the computer network, and that device uses network internet protocol for the communication purpose. So in computer network, every device, every computer have its own IP address, and in the same way in IoT based system, every node and every physical device have its own IP address. An IP address serves two main functions. First is host or network identification and location addressing. These two are the two main important functions: network interface identification and location and addressing. Internet Protocol version 4 defines IP address as a 32-bit number. IPv4 defines IP address as a 32-bit number. And because of growth of the internet and the lack of availability of IPv4 addresses, new version IPv6 were standardized in 1998, and IPv6 consists of total 128 bits, and its deployment, IPv6 deployment, has been ongoing since the mid 2000s. Now next is IPv6. This is Internet Protocol version 6. This is the successor of IPv4 and developed by Internet Engineering Task Force to deal with the limitations of IPv4 address scheme. Basically, IPv4 address is not is only 32-bit long, so it can provide limited addresses. And IPv6 uses 128-bit address, and theoretically it allowed 2 to power 128 IP addresses. So this will be now these this is low power wireless personal area network, and next we will discuss in next video. Thank you and have a nice day.